Okay, it's a couple of minutes after 3, so we're going to go ahead and get started. Welcome everyone to our last session of the day. It's innovative technology. And as usual, we're using the chat box for any questions that you have. You can send them to me or the presenters. And if you're calling in, you will need to email me or Chelsea, and we will be happy to pass the questions on to the presenters. So with that, our first speaker is Farella March with ODEQ. Farella, I'm going to pass it over to you.
Okay, hi, good afternoon, everyone. I didn't know we were the very last session because usually the last session everyone's falling asleep, but I think Dr. Clark might have a remedy for that. I'm assuming everyone can see my slides, and so that's good. And I'm just really happy to be here. I know many of you. I'm Farella March. I'm the manager of the Used Tire Recycling Program at the Department of Environmental Quality. I've also worked with many of the tribal members on the OCRMIT, which is the Oklahoma Kill Response Management Team. And that's where we investigate fish kills. Has nothing to do with tires, but just to kind of give you some reference, that's kind of my background, kind of going from wildlife, so really about ecology and systems to tires. And then also at the end of this month, I am retiring. So this could be my very last presentation that I will be giving in the environmental field. And I will be moving on to a new vocation, and that is counseling. So if anyone needs help in that area, you can probably Google me and find me. So anyway, so let's get started. I'm really happy to be here also with Dr. Clark and with Kevin Suter with the Oklahoma Department of Transportation. And I hope that we have a trilogy that you can get a lot out of, and I hope that you have some good questions. So let's go ahead and get started. So today I'm going to be discussing the problem with tires and why we care about a sustainable market for them. We're going to explore what the sustainability looks like, especially from a cultural perspective. I'll be discussing market trends nationally and in Oklahoma, and we'll briefly go over the advantages and disadvantages of one of the ways we are using scrap tires in Oklahoma as rubberized asphalt. But I'm really going to leave a lot of that up to Dr. Clark to discuss. And then last, we will take a peek at how we can move forward using scrap tires in roads as a sustainable alternative to lower end markets. So before we dive into the concept of sustainability, I think we need to identify what the problem is. And this problem, yes, is tires. The problem with tires is there are a lot of them everywhere. And Oklahomans purchase approximately 4.7 million tires per year. In fiscal year 2017 through 2019, Oklahomans purchased an estimated 14.1 million tires. And these numbers are based mostly on just regular passenger tires. In Oklahoma, an estimated 11.5 million tires were recycled, and this trend continues today. So this hasn't changed. We're continuing to recycle a lot of the tires that are generated. Approximately 135,000 tires remain in tire dumps across Oklahoma that we know of. There could be a lot more, but these are the ones that we know of. So what does this mean? Well, this means this leaves approximately 2.6 million tires still out there in dumps, at tire dealers, at communities, you know, the tires that people have, that communities have collected during events, and at receipt locations. These are mostly, you know, places where they have fleet vehicles, and landfills. Okay, and I'm trying to find my chat box. I think I'm seeing some of them come up. So I'm gonna try and address that here real quick. There we go, got it. So give me 1 second here. Okay. Thank you, Wes. Okay, so now that we've identified the problem, we can talk about how we can utilize scrap tires using a sustainable market. And let's take a look at what sustainability looks like from a model perspective. So this particular definition of sustainability, development that meets the needs of the present without compromising the ability of future generations to meet their own needs. This is, defining what sustainability is pretty difficult, but this is probably the most popular definition and probably the easiest to get your head wrapped around. And it is important to note the inclusion of both present and future generations, because sustainability is about encompassing the big picture. The three main tiers of sustainability are the environment, economics, and social and cultural factors. Sustainable solutions are found somewhere in the middle. So you can think about in this model that sustainability lives right in the middle. And the interesting thing about sustainability is that it requires all three of these tiers to be recognized and included. So when we talk about sustainability, if we leave out economics, it's not sustainable. And the same goes for including social and cultural values and environmental impacts. If we leave social and cultural factors out, it's not sustainable. If we leave the environment out, it's not sustainable. Sustainable solutions are interconnected and they must account for future generations. So when considering sustainability, you might want to ask yourself a few questions. So for example, how do my actions affect the environment? How do my actions support conservation or development efforts? And how do my actions preserve ecological diversity? How do my actions preserve and respect cultural integrity? How do my actions impact generational resiliency? So ecological diversity in Oklahoma is interwoven into our overarching environmental health and well-being. And we know that diversity is really good, but the landscape becomes a whole lot less diverse when development of markets leaves out the environment in the sustainability model or leaves out some other tier in that sustainability model. Right now, we're going to kind of focus on the environment tier of the sustainability model, and we're going to talk a little bit about ecological diversity in Oklahoma. So Oklahoma has 10 or 11 ecoregions. This just depends on the expert. I was always taught that we have 11 ecoregions, which is great because that means that we beat Texas. So as you can see from the map, this puts us third or fourth in the country in ecoregion diversity behind Alaska, California, but not so much Texas since we have 11. For such a small state, we really have an incredible amount of ecological diversity. And this diversity results in dramatic differences in our habitat, soils, plants, and of course, weather conditions. It's not unusual for Oklahoma to experience ice storms, drought, tornadoes, and flooding all in the same year and in different parts of Oklahoma. I think we experienced that in 2020. And some of the ecoregions in Oklahoma, I know many of you are familiar with these, but they include the Western High Plains, Cross Timber Forests, cypress swamps, and tallgrass prairie. All of these are found in Oklahoma, and each of these places represent different advantages and challenges for land use, whether that's for development or conservation. I've heard some people say that you can pretty much divide the state along I-35 and I-40, chunking it up into very different landscapes. And within each of these four sections, the subdivisions represent really diverse and rich systems. So when looking at the sustainability of a new market, you also have to consider the impact it could have on an economic level or a social level, which of course could have either positive or negative impacts. So we looked at the environmental diversity part of the sustainability model, but now let's take a look at the economic and social diversity in Oklahoma. So I'm going to throw a lot of numbers at you here for just 1 second. According to the U.S. Census Bureau, the population of Oklahoma is 3.9 million people. And if you will recall, Oklahomans purchase about 4.7 million tires per year. Excluding about 31% of individuals under the age of 18, this puts our tire generation in Oklahoma at about 2.2 tires per person. So let's take a look at the race breakdown. So while Oklahomans are primarily white, the American Indian, Black, and Hispanic populations collectively contribute nearly 30% of the population in Oklahoma. And these numbers really only reflect the data received through the U.S. Census Bureau. So we may have, more diversity actually in Oklahoma than what is reflected in the census. 88% of the respondents to the Census Bureau have a high school diploma or higher, and 25% have higher education degrees. 11.5% of our population under the age of 65 have disabilities, and 17% do not have insurance. Most of our labor force is civilian with a mean household of $52,000, and 15.2% of Oklahomans live in poverty. In the year 2020, the unemployment rate in Oklahoma was at 6.1%. This is an increase from the previous year when the unemployment rate stood only at 3.1%. But it's down from a high of 6.6% in 2009. So now, why did I just show you all of these numbers? What does it matter? Well, I wanted to drive home the point that Oklahoma is diverse, but also that the market has to make sense economically and provide a need. So we all know that Oklahoma is rich in tribes, contributing to a wealth of cultural diversity. And this slide just shows all of the tribes based out of Oklahoma. Tribes encompass much of the history in Oklahoma and contribute unique cultures, languages, and tradition. And due to their sovereignty, tribes also add important political intersections to Oklahoma. Cultural diversity is unique to Oklahoma because of the number of tribes and the political landscape that this creates. As mentioned earlier, tribes offer cultural richness and tradition, however, not without issues related to economics, the environment, and their social well-being. So I just wanted to share a little bit with you since I've been working for the state for 27 years, and a big part of my career I've really worked with tribes, and over this time period I've really learned a lot. And one aspect I have come to understand about the American Indian culture is the importance of their philosophy of life and community, and the significance of cultural resources. And of course, this relies heavily on the environment, a healthy environment, not only for the current generation, but for generations to come. So earlier I talked about markets needing to be sustainable. High-performing and environmentally conscious roadways are part of the sustainability model and a path to generational viability. So what if I told you that there is a way to build better roads that last longer, are safer, and use recycled products? I wonder if you would believe me. Well, what if I told you the way to better roads is by using a recycled product made from old tires? Earlier, we talked about tires and how abundant they are in Oklahoma. And tires they don't really decompose, and they can really be an environmental hazard. For example, many of you know that one of the tire recycling facilities in Bristow has been on fire the last couple of days. So this does create quite an environmental hazard when tires do catch fire. They also attract mosquitoes, snakes, and other vectors of disease. They're also just very unsightly, and they just kind of, they're big and they get in the way. So in contrast to diversity though, which I've been talking about over the past several slides, monofills like this one is where tires in other states, not Oklahoma, fortunately, but in other states, for instance, Colorado, is where the tires spend the end of their life cycles. So even though we don't have these types of structures in Oklahoma, we do have an abundance of tires, as I discussed earlier. So while we have markets in Oklahoma, we really lack a diversity of markets. So let's take a look at the national markets and local trends here in Oklahoma. So generally speaking, national data indicate more tires are generated than utilized in markets. So this trend has been stable for at least a decade. The deficit of tires making it to market is why we want to increase markets across the nation. So the total annual generation of tires across the nation is, just thousands of tons of tires. And the dominant market right now is it's tire-derived fuel, but that has kind of dwindled over the last couple of years. And crumb rubber has really picked up in terms of markets. So when the markets are down, more of the tire-derived product ends up in landfills as alternate daily cover. And use of this tire-derived product for civil engineering projects remains really an emerging market. And there are some folks across the nation who have done a fantastic job in really creating that market as a viable market. Civil engineering projects might include things like backfill material for septic systems, basements, and even roadway bedding. So other smaller markets include reclamation projects such as stream and bank erosion projects. We used to have some of these in Oklahoma, but we don't currently. There are some that have kind of broken apart, and now many of the tires end up in the streams. Fuel for electric furnaces and exports are also really good markets across the nation. Not major markets anymore, but they still fulfill a need. So there is there's also some tire-derived product at processing plants as inventory. So this is just kind of stockpiled. So since we talked about ground rubber as being kind of a primary market, at least now across the nation and in Oklahoma, let's take a look at that a little bit closer. In 2017, most of the ground tire rubber produced was used in molded and extruded products such as carpet, underlay, flooring material, dock bumpers, patio flooring, railroad crossing blocks, and roof walkway pads. I mean, there's just a lot of roofs and then walkway pads. So I don't know if you all have been down to Scissortail Park in Oklahoma City, but that is made from recycled tires. Part of the path is. And so just next time you're there, just kind of pay attention to it and you'll see what I'm talking about. Playground material and mulch is also a very popular product. It was very big, kind of went away. Now it's starting to come back a little bit. Recently, there's been a controversy about GTR being used in artificial turf. And a lot of that surrounds concern about exposure to ground tire rubber particles causing cancer. Recent research has indicated a low risk associated with its use, especially in artificial turf. Now this research is ongoing. There is research out there, but I think that there has been subsequent research in addition to what they looked at initially. A smaller percentage of ground tire rubber is used in automotive applications and exports, and that would include things like muffler, hangers, insulations, and soundproofing, and also some molding. And then some ground tire rubber is exported out of the country. So the market I will discuss more of today, and what Dr. Clark and Kevin will talk about, is the use of ground tire rubber in asphalt. So Oklahoma markets are very similar to the national trends. The major market in Oklahoma currently is crumb rubber, and right now the crumb rubber market is mostly lower end markets. However, Oklahoma is trying to expand its markets to include rubberized asphalt. And like I said, Dr. Clark and Kevin are going to talk more extensively about that. So a current challenge, though, is the inability of Oklahoma processors to produce a mesh size small enough to meet the specifications needed to use as a polymer substitute in asphalt binder. And so that's one of the things that we're working on, is just trying to demonstrate that the market is viable so that our processors will start to produce the needed product. So let's pause for just a moment and consider the advantages of using ground tire rubber and asphalt. Well, first, ground tire rubber improves elasticity and allows for expansion of the asphalt. Increased viscosity helps to prevent rutting and cracking. So all that rutting and cracking that you see along the road, there's a reason for it. The roads last longer with GTR, that's at least what the trend is, and there are fewer loose aggregates that can fly up and crack your windshield, for instance. And Dr. Clark, I know, is going to expand on this a bit in his presentation. So since ground tire rubber is such a mouthful, I'm just going to call it GTR at this point. So GTR allows for better friction, which means fewer accidents. Roadways that contain GTR also retain their color better. So you might notice that the roads are blacker. GTR improves ice control, which is a plus really, especially here in Oklahoma. And GTR also results in roadways that produce less spray, which means better visibility. And this is like my favorite advantage of GTR, of using GTR in asphalt, is the spray. Because I don't know if you've seen a comparison of a road that uses GTR in the asphalt and a concrete road, and you can just really see the difference in how much spray is produced by cars. So while there is a wet and a dry process, Oklahoma is currently using the dry process for roadways or for our demonstration projects on certain roadways to really show how sustainable this market is. The most notable advantage of the dry process is that it is more cost effective than the wet process. And like the wet process, it increases performance grade. And this is really key because you can go from a lower performance grade and you can increase that performance grade, making it a better road just by using GTR. So in other words, if it produces a more durable road, especially during weather extremes, and we have all those. I showed you a slide of all of the different weather extremes that we tend to have here in Oklahoma. The dry process also results in reduced stickiness, which makes the mix easier to work with than mixes associated with the wet process. And the contractors really like this much better. So this improved workability means contractors really like it. The dry process saves money because the lighter material preserves the equipment. And it is also more affordable, which means the dry process is really more desirable. So as far as disadvantages, we'll talk about those just for a few moments. The dry process is relatively new in Oklahoma. And in the past, a lack of standards and specifications create an obstacle for Department of Transportations. And Kevin's going to talk about that more, about all the work that he's done with regard to getting some specifications for the use of GTR in asphalt. A lot of testing has to be conducted and mixed designs developed to create these specifications. So it doesn't happen overnight. Over the past couple of years, like I said, ODOT has made great progress toward creating a specification for GTR, and I'm really excited that we're about to move forward with this. So, but regardless of how exciting something might be, when it is new, it can be pretty scary for a lot of us, right? And it's like, well, it's like pretty much, I actually picked this slide because one of the scariest things that I can think of is jumping out of an airplane. And, and I know a lot of people say once you jump out, it's easy peasy, no problem. You just you get used to it. You feel wonderful. But just making that initial jump can be pretty scary for a lot of us. So what lies ahead for tribes and other local governments? Well, Dr. Clark will talk about this in more detail, but in brief, GTR can use 600 to 1,000 tires per lane mile, and savings can range from 5 to 20%. So what these numbers mean is that tribes can lay down a road that is cheaper and more cost effective, better for the environment, and pave more roads within each nation. And recall our sustainability model. The use of GTR has met the economic, the environmental, and social and cultural requirements for sustainability for it to be possible. And so, and as I mentioned before, sustainability lives right here in this intersection of environment, economics, and cultural factors. So imagine what the future might hold with regard to roadways. GTR and asphalt meets all of the requirements for sustainability. GTR uses recycled tire rubber and is therefore a better environmental option. And GTR in asphalt offers fewer obstacles than we tried to implement, than what we tried to implement in a similar market a few years ago. So GTR is also cost effective and it lasts longer. And it is possible that more roads can be paved, especially in some of the rural areas, allowing for better access, and especially during some of these extreme weather conditions. Okay, and since I'm no longer going to be around, if you have further questions about what we're doing as far as market development goes in the tire program, you can contact Cole Kennedy, and I've included his information here. Okay, and then these are just my references in case you needed to see them. Okay, and then I think, Karen, you wanted us to go to the chat box and just see if there are any questions. Is that correct?
Yes, please.
Okay, so
did you have any in yours?
I did not. I did have a lot of congratulations, so thank you very much, everyone. Yeah, I'm gonna miss you all so much, and I'm gonna miss ITEC conferences and really working with the tribes. Hopefully, I'll be able to somehow work with tribes again in my new career. So,
well, we're gonna miss you also. So, okay, so if we have any chats, we'll check back again towards the end of the session. So, our next presenter up is Dr. Redmond Clark with Asphalt Plus. I am giving you presenter privileges, Redmond, passing them to you now. So I will give you the floor.
Okay, can you hear me all right?
Yes.
Okay, I will share content with you now, you poor people. We'll see if we can't drill down a little bit in terms of where Farrella has taken us so far. I'm going to talk in greater detail about dry process rubberized asphalt and try to kind of take you from the theoretical into the practical realities of the technology and what it should be able to do for you. Before I begin, though, let me just tell you very quickly what our companies are all about. TDJ Group is a specialty chemicals manufacturing company, and Asphalt Plus produces a specialty chemical that is chemically modified from rubber that goes into the asphalt process. Now, we're a sustainability focused company, so we help various industries reduce the amount of toxins that they generate by re-engineering processes. We assist in renovating contaminated properties that have been left behind by old industries. We work with the removal of contaminated coatings like lead paint and do so while creating a non-toxic residue. And of course, we're recycling ground scrap tire rubber into asphalt pavements. Our overall thrust is that we're trying to reduce the environmental footprint of man through individual companies, and we reduce or eliminate waste generation altogether in selected industries, and we create an economic benefit for the industries as well. And as Farrell pointed out, with the intersection of various components of societal goals, we try to create something that's of value for everybody that's part of the sustainability equation. Now, if I can, I want to maybe reemphasize some of the points that Farrell made very quickly here so that you understand our perspective. Before European settlement, the pre-Columbian Native Americans essentially had a pretty sustainable relationship with the environment. They didn't have huge cities, low density settlement, agriculture, hunting, gathering, relatively minor impacts, a light touch on the environment. And as a result, as a society, they didn't create what are called externalities to a large degree. And by externality, that's an economist term, and it means throwing something away and just assuming that nature is going to take care of it for free. So if you dump it in the river, it's gone, no problem. If you put it up into the air, it's gone, no problem. If you lay it down on the land and walk away, it's no longer an issue. When the European cultures were introduced into North America, one of the really fundamental changes that happened was that they believed that personal ownership of land was a critical component of their economy. They believed that because they owned the land, they could bend the land, if you will, to their own uses to generate profits. So they came in with much higher settlement density, monocultures, accelerated resource consumption. And again, they believed that externalities were free for the taking, only they didn't see any reason to limit it. They just let it go. And as a result, we've seen an extended period of very significant environmental impact here in North America. Now, the downstream effects we understand, I think, better than we had in the past. But as we get more and more people on the planet, we see that these externalities are starting to add up to the point where the bills are coming due. And if we step back and look at what's happened to water pollution, depletion, soil pollution, erosion, limits to growth in extractive economies like finding resources that they can dig up out of the ground, impacts on the oceans, on the atmosphere, essentially what we're seeing is that the rate at which these externalities now are piling up, we can't sustain the environmental envelope on the planet. Now, in 1992, the United Nations, in an attempt to begin to address some of the climate change issues that were coming before it, invited a number of Native American and other speakers to come in and talk about the whole concept of sustainability. And one of the speakers was a member of the Hopi Nation, Thomas Banyasaya, and he spoke of a spiritual path that included caring for the land and the people that lived on it. And he said, we've got a stark choice in front of us. We can try to live with technologies that keep us separate from the environment, or we can try to live in harmony with man and with nature. And he said, the second path leads to chaos. The first path leads to a degree of salvation for all of us. And his words were powerful, and I think his point was well taken. But the opposing force to what he offers is the public's focus on profit and on free lunch as part of that profit model, which is the externalities. We want them to be free. So today, if I went out and I polled Americans, I'd find that better than 85% of Americans would agree that we've got to do something significant about climate change. But when I ask them, how much are you willing to spend out of your own pocket to help solve the problem, the support pretty much falls below 50% when the bill is more than $20 to $30 per month. So essentially what people are saying is, well, we want these externality related problems fixed, but we want them for free. Okay, and in a sense, they're resisting personal accountability. They're not really changing the way that they live in any material way. And again, I'm speaking in very broad generalities here, not on individuals. And companies and even governmental agencies oftentimes segregate their primary thrust, which may be focused on providing a service or generating profitability, from sustainability actions. And they're not necessarily flowing together. And it creates a fundamental question for us, maybe an existential question for humanity, which is how do we get everybody on the right path? Because clearly something is going to have to happen. So if we look around us, we can see evidence of huge change. And I won't spend a whole lot of time on all the different things that are going on. But I would just offer this, that we're building a city the size of Chicago every 6 weeks on this planet, and we are going to continue doing that for the next 25 to 30 years. So we are clearly going to have an enormous impact on the receiving environments of the planet as a whole. And as these externalities begin to continue to add up, what we're going to find is going to begin to show up in our political discussions and in our political debate, because we've got to change the civil infrastructure to reflect changes in climate, reflect changes in material availability, reflect changes in economics that are associated with all these other changes. Well, the world is slowly bending in the direction of sustainability, but there is an open question about what can we do now to begin to have an effect. And that is where we try to find paths towards sustainability that are going to be supported right away. In general, if you look at the problem globally, about 50% of the sustainability problems can probably be addressed for free, meaning that if we can get things oriented in the right way, resources allocated in the right way, we can start addressing a lot of these complicated problems. Okay, at least moving down the road towards getting them addressed. And that's the space that we work in. That's where we're focused, and that's how we got involved with using tire, rubber, and asphalt. So I'm going to spend my time, what time I have left here, just quickly talking a little bit about how we make asphalt and what tire rubber can do, how we use it, and what it means from an economics standpoint. Now, Farrell did a good job of kind of covering the basic elements of what I'm going to cover here, so I'll just touch on some of the high points. In terms of making asphalt, it's a pretty straightforward process. It's actually very complicated, but understanding it is straightforward. We're going to take various kinds of stone and sand and mix it together with a tar that is solid at regular temperatures and liquid at 300 or 400 degree temperatures. Mix them together so that the tar coats all of the aggregate. We place it down on the ground, and then we compact it once it's put down in a very smooth layer. That's how we make roads. You've seen it probably happening around you every summer during construction season. And these are strong, durable roads. When they're put together properly, they're a great asset to the economy. Now, the enemies to the roads, as Farrell pointed out, are actually in two separate categories. One is physical changes to the road, cracking and rutting, and the other is money. Most paving programs, and I dare say this is true in all the tribes and most of the counties here in the state of Oklahoma, there's not enough money. There hasn't been enough money for the last 20 years. And so with underfunded budgets, states are constantly being pushed to try to find creative ways to help counties, communities, tribes come up with ways where they can pave more cost effectively. Okay, the road engineering programs are kind of faced right now with a choice. They either get more money or they improve the life cycle cost of roads, meaning they make roads last longer, or both. And that's kind of the box that all of us are in right now when it comes to managing the roads in the US. There are lots of mixed designs, many different binders that can be used to make asphalt mixes. Some of them are better in cold weather, some of them are better in hot weather, some of them are better with light traffic, some of them are better with very heavy truck traffic on them. There are many different kinds of aggregate that can be used in these mixes, and there are additives like recycled asphalt pavement, fibers, and tire rubber that can be added to the pavement in order to both reduce its cost and extend its life. All of these roads are designed for particular uses in their area. An agricultural road is not going to be built the same way as an interstate highway, and they're not going to support the same amount of traffic. So we have to take all of these different pieces and find a way to mix them all together so that we can come up with the right mix for the right road at the right time. Now, one thing that we've learned, as Farrell pointed out, was that if you put rubber into roads, you're going to get a lot of benefits from it, okay? It'll make the roads more rut and crack resistant, better traction, quieter roads, and it's generally viewed as a positive. But I'd like to drill down a little bit and explain exactly why this happens, and I'll be able to show you graphically in a couple of minutes here. We take the tires and we reduce them down to very, very finely ground rubber, much finer than what you see in this picture in this person's hands. But we use ambient and cryogenic grinding. Ambient is cutting it with knife blades. Cryogenic is freezing it in liquid nitrogen and shattering the rubber into small pieces. Either way, we end up with a very fine powder. When that powder is put into asphalt binder, the rubber will soften, it will swell up, and if you cook it long enough, it'll start to break down into tiny little pieces. Okay, this is the normal interaction between rubber and asphalt binder. Now, if you take a look at a hot asphalt binder, a mix, I should say, that's been put down on the ground after the rubber has reacted, you can see that when it's hot, the rubber is pretty soft. It's actually pretty sticky. That's the tip of a needle. But that's going to act to block any kind of a crack that moves through there because that tire rubber does not break apart very easily. So I can show you here a quick example. This is a brick of regular unmodified binder, no rubber of any kind in that binder, just regular binder that comes out of an asphalt, an oil production plant. And we put this on a jig, cut a notch down the middle of the brick, and we pull it apart with those two silver bars, and we measure how much energy is required to break it apart. This is a standard asphalt binder. It breaks apart in about 30 seconds. Okay, so that kind of sets the standard for resistance to cracking apart. Now, if we take state-of-the-art asphalt, you're looking at that notch cut in the asphalt at the center of the picture here. And if you look, this material has been modified with a synthetic rubber product that is melted into the asphalt binder, making the binder and the mix more flexible and more cracking resistant. And so if you look, the original binder took about a half a minute. This binder takes 4.5 minutes in order to break apart. And the amount of fracture energy or the resistance is tracked by that graph down below. Okay, so we know that if we improve with these polymers, we can get more resistance to cracking, and that means the road's going to last longer. Now look what happens when we put crumb rubber in. Watch that notch again, and you'll see that we pull and pull and pull and pull and pull until finally it slowly tears apart. And unlike the regular binder, 30 seconds, the polymer modified binder, 4.5 minutes, it takes 35 minutes for this rubberized brick of binder to pull apart. And it actually breaks differently as well. So what we're seeing is that when we put more rubber into the binder compared to the original binder over on the far left, or the polymer modified binder on the far right for heavy traffic roads, you can look and see that as we add more crumb rubber, we get more cracking resistance. And that's the kind of resistance that brings value to the equation in terms of putting rubber into asphalt. We can look at the faces of the fracture and we see that the polymer and the standard binder break like glass, whereas the rubber requires the mix to rip that crumb from one side or other of the fracture as it propagates. And that's why there's more resistance to cracking. So as Farrell mentioned, there are two general ways to produce these mixes. One is the wet process, the old method, where we add rubber to binder, we cook it for an extended period of time, and then we ship that rubber modified binder in a truck over to a plant where it's pumped into a tank and then pumped into the mixing process. The new method is the dry process, where we add the rubber after it's been chemically re-engineered like a fine aggregate into the mix. Now, the terminal blend process, we don't have to spend a lot of time on it. Farrell kind of described it for you. Really, there's only one or two important points about this process. It produces good quality pavements that are very durable, just as durable as polymer, but it's very hard to mix at the asphalt mix plant, and it's very expensive. And that is a critical issue for any kind of an asphalt mix. Now, if you take a look at the dry process, we take bags of crumb rubber that have been engineered, we bring it to the plant, we feed it into the plant through that fiber machine, that blue machine you can see on the right-handed picture. If I may, I've got a quick video that will show you the process in about 60 seconds. Now, in order to make this process work, we ship in by trucks, we ship in a very carefully manufactured crumb rubber product. It's fed in through that feeder system that we were talking about a moment ago. And that feeder system very carefully meters the rubber into the process. We cut the bags open and we fill the surge hopper so that every time that feeder starts to run low on rubber, the feeder can refill itself with the rubber that it's got in the spare container there. This allows the plant to continue without any kind of an interruption whatsoever. You can see here that the rubber is now being dumped into the main feeder. The main feeder is going to continue to feed that material into the plant itself. The material comes out of that feeder, it's metered into a hose with air blowing through it, and that material blows into the drum of the plant, and the rubber is mixed in, and it gives us that modified asphalt. Now, unlike some rubberized asphalts, which tend to be pretty sticky and difficult to handle, this material handles like a regular hot mix. It goes easily through the plant, into trucks, out of the trucks and into the paver. And you can see that it's sliding off the steel of the truck bed. It is not getting stuck there. And it's very common to see a perfectly clean truck bed when this material drops off. That's really important because the stickiness of a rubberized asphalt has been one of the primary objections that users have made to laying this material down on pavements. So we see this material being laid down, and it's laid down in a nice tight layer that is very, very level. And behind the paver, we have rollers that are essentially going to track behind and compact this material down and give us that fine finished surface. And again, with the rollers, we see that the mix doesn't stick to the rollers themselves. So, do we recycle a lot of tires in the US into roads? And the answer is, well, no, we don't. And that's kind of a surprise because we see an awful lot of benefits here. And the reason why is that the old process is best known and it's been specified in the past by DOT, but the contractors didn't like and don't like the process. It's too hard to use, it's too expensive. And for a contractor that lives in what's called a low bid environment where they have to be the lowest bidder to win a job, they're not interested in picking up a process that costs more than any alternative that's out there. So as a result, rubber hasn't been used very much in the United States unless the state mandates that you must use it in pavement. So the dry process was designed to break the logjam. And here's essentially what we have to contend with. We've got to convince the DOTs and the contractors that it's a fit, okay? We need to know that it works in the field from an engineering standpoint, and we need to know that the pavements are durable, and we need to know that the pavements are acceptable to the contractors. Contractors say, hey, give us something that's simple to use, give us good quality pavements, and more importantly, cut our costs, and we're interested in the process. So when we kind of walk through this technology and see what's happened in the field, we find that the engineering is pretty simple. We find that it's been pretty widely used with a lot of material that's been down for as much as 20 years. We've got now, we're beginning to approach 7 million tons that have been placed on the ground. Some of these projects by themselves are 150,000 tons of mix. And you can see we're in all kinds of environments around the United States, but we're also getting busy over in Europe. And you can see that the dry process now is starting to be adopted by a number of European nations as well. So when we look at our field experience, we see that we've got 20 years in the field. We've got lots of different climates, mixed designs, local roads, interstate highways, extreme climates. It seems to work out pretty well. Now, I'm not going to sit here and bore you with a whole bunch of stories about how wonderful the product is, but I want to look at just a couple that would be of interest to Oklahoma. The first project is actually in the northern plains, and it was used in an area that gets cold snaps, and the cold snaps typically can cause what's called thermal cracking, which is a particular type of cracking caused by cold weather relative to the kind of binder that's used in a mixed design. And as you can see here, the engineered crumb rubber has been more effective in blocking thermal cracking. This is the right-handed picture, and this happens to be on a very busy interstate highway. So we know that it's going to perform well when you've got some extreme cold snaps, kind of like you did last winter. The various entities that use this technology like to look at it from a balanced mix design standpoint. They want all their mixes up in that right-handed upper quadrant. And you can see where it says super mix and passing, and you can see those blue dots. Those are rubberized asphalt projects that show minimum rutting and high resistance to cracking, which is exactly where they want these pavements to be. The second is a little closer to home, especially for this audience. This is a moderately used road, an old concrete pavement that was spalling and cracking. And the Texas DOT in the Fort Worth area decided that they were going to repave this area with an overlay made of hot mix asphalt. The plan was a 2-inch overlay. The expected life was 10 years before they would significantly rework or mill and fill the pavement again. And instead, they decided to put 1-inch thickness, half thickness of rubber modified asphalt and polymer modified asphalt in its place. So they covered this kind of a pavement with an asphalt pavement that went down in 2007. In 2018, Texas DOT went back and looked at the pavement and they said, boy, it's not oxidizing as fast as we typically see here in the area. It's not cracking the way our regular pavements do. and the rubber isn't rutting the way our pavements typically do. And what they projected is that this is going to last for 25 instead of 10 years. So they used half the thickness for more than double the life of the pavement. Now, we've also found in some areas that we can increase the recyclables in the pavement. That's a good deal from an economic standpoint, and it's a good deal from a sustainability standpoint. We're not going to spend a huge amount of time on that, but that's another area of real opportunity. So when we take a look at sustainability economics, and remember, Varela was saying that the economics is an important part of this. It's very important for the DOTs, and it's very important for the contractors. So we know what we have to tell the paving industry, okay? The paving industry, it's not that they don't care about sustainability, but they've got to get the roads built and they've got to honor their economic commitments in terms of budget. So they're constantly trying to find ways to be better, but not necessarily driven by environmental factors. It's economics first. Change happens when we can address all of the needs of the industry. And as I've indicated here, and as Farrell has indicated, we're addressing good roads, easy production and lay down, and cost savings. But I'd like to drill down a little bit on cost savings. In general, if you can save 50 cents per mixed ton, you're going to get the attention of industry. Here's a quick synopsis of what we see with this particular technology. First off, we find that we can remove or reduce the use of various kinds of additives and mixes like slip aids to get material off trucks, workability additives, and viscosity adjustment additives. They're typically not required in various mixes. And as you can see here on the left, this was a polymer modified asphalt, and on the right, a rubber modified asphalt. And in the case of the left example, the binder is all at the bottom of the jar, and the rubber has held the binder onto all the aggregate throughout the mix, which is a really good thing. Secondly, we reduce waste. Remember, those trucks come off clean, the pavers come out pretty clean, and as a result, we don't have a lot of waste material that gets cleaned out of the trucks. Thirdly, we can save a lot of money when we put recyclables into the mix, especially as we increase the amount of recyclables in the mix. And I think down the road right now, Kevin is going to be talking about the work that they've done just to kind of clear this process so that they can start using it with small amounts of recycled material, primarily RAP in pavement designs. There'll be some opportunities down the road to experiment on using more recycled material and cutting costs. Finally, when we're dealing with heavy traffic roads and we can replace polymers, we can save sometimes as much as $3 per mixed ton. And in lighter duty roads where we're putting in an overlay, we can save anywhere from $8 to $20 per mixed ton by reducing the thickness of the pavement. Bottom line is that if 50 cents is a magic number in the industry, we're talking about something far, far and away cheaper than what we would see otherwise. And this is really important when it comes to any kind of a road agency that has got a limited budget. And those are tribal agencies as well as cities and counties throughout the state of Oklahoma. This represents an opportunity for them to bring in a new technology and begin cutting their paving costs and beginning to catch up with their paving obligations. So where do we go from here? I'll be very brief and just say that what we would ask is for those of you that are involved in tribal governance, take the word back to your leadership and let them know that this is an option that you might wish to consider. If you do, it is something that we would be happy to work with you to sort out, and especially if you own your own plant on tribal grounds, you know, we can help you in terms of finding a way to adjust the plant and getting it operating so that this is an option for you. But the core message that I'd like to offer is very simply this: this is one way to begin moving in the direction of the right path, and it's something that we're committed to as a company, and we'd be happy to work alongside you to try to make that a reality for whatever jurisdiction you represent. So with that, I'm going to open this up for questions. I'll just show you a quick video of some paving that was just finished in Switzerland. And as you can see, we've got nice smooth road surface that is operating at a very high altitude environment with a lot of cold. So with that, I believe I now have to go and find my chat box and see if any of you have raised any questions. And I do not see any questions in there. So if I can, I'd like to pass this back to you, Karen. And if you have any questions, I'll be happy to answer them.
Okay, Thank you, Redmond. I don't see any in the chat box just yet. And also, if folks are calling in, you can email me or he just put his contact information on the screen. But if you want to email me, that's great, or Chelsea, and we'll be glad to pass it along to the presenters. So up next is our next presenter, and he is Kevin Suter with ODOT. And I am giving you presenter privileges, Kevin, so you can share your screen. And we'll go back and look at the chat box in a few minutes. Okay, Kevin, you have the floor.
That'll be great. Everybody can see the screen? Not yet. Now you
Not
should
yet.
be able to see, right?
It's starting to, yeah, it's starting to share now.
There we go.
Yep, we can see it.
Well, thank you for your time. And I'm the last person of the day. So just to let you know, I've got about 50 slides to get. No, I don't. I've got about 6 or 8 slides to get through. And we're just going to talk just a few minutes about the specification challenges. Why, you know, as a specification challenge, I've got to talk the wet stuff too. I really like the dry process and what it gives and the benefits from it. I worked on the other side. I worked on the contractor side for about 30 years, and we did some wet process work. And it's well, we won't go into that. I can tell you that as a ex-contractor, I much prefer the dry process to the wet process. So what we're going to talk about just real quick is the background of why we use tire rubber. Then we're going to talk about the wet process or the terminal blend, the dry process, and then future. And so if we're on track in about 10 minutes, we'll be good. First, the background. In 1991, our friends in DC put into legislation that 10% of all mixes put on federally funded projects will have ground tire rubber in it. And at the time, this was a wet process. Well, they were going to start in 1994. But what they really didn't figure on is they didn't give a lot of time to the rubber people and the construction people to figure this out. And they withdrew the mandate in 1995. So, you know, with that, there was a proliferation of GTR specifications. We still have copies of the stuff that we had back in the early 90s. Oklahoma Department, you start in the wet process with specifying the liquid part of the hot mix. So ODOT wrote specification for an AC20, which is the common AC at the time, but they wrote it AC25 TR. TR meaning tire rubber. And then once in the middle to late 90s, when ODOT adopted the PG grading, they went to a 70-28 TR, which is a terminal blended, as Super Pave was introduced. Well, ODOT during that time placed several projects across the state, and there still are a few still in place. I was out on a project a couple of years ago, and it was placed in the mid-90s, and the road was cracking pretty bad, but we got out and took a look at the cracks, and you could still see the rubber stretched across the cracks. So rubber and asphalt, I think, has its place, and it's just going to be another tool in the toolbox for our residencies and our districts to use to try and help some of their issues. So we talk about the terminal blend or the wet process. The issues, we talk about issues, both the wet process and the dry process. Sometimes the manufacturers aren't prepared for the volumes that are demanded. Right now in the state of Oklahoma, there are two suppliers of the wet process, and both of them are in Texas that manufacture it down there. And as a matter of fact, one of them is shut down because they had a safety issue in the plant. The project was supposed to go early next week, and they shut the plant down, and that project fell through. It's up in the northeast part of the state. They also found out that contractors really were apprehensive about storing the product. I for one, have seen pictures of them pulling. They let the asphalt go cold in their plant, and they had to pull the piping apart and pull out a big, huge, long snake of rubber asphalt. That so there are additional concerns in a plant storing it and operating it. And then the distance to the terminal. Like I said, they were going to go up into the far Miami area next week, and the asphalt, the Grand Tire rubber asphalt, was coming from South Dallas. So, just a lot of time on the road and a lot of things to be concerned about. One system actually put the blender at the asphalt plant, and there's a lot of work in the wet process. And I haven't heard of anybody doing that right now, that it's such an intricate process. And then the good issues, there's not any extra equipment needed as far as once you bring the liquid in to the plant. The recent project with Terminal Blended in Oklahoma was State Highway 3W and Ada, in front of the District 3 offices. Haskell Lemon was the contractor using Wright asphalt. You go down and take a look at it, it's performing pretty well. The next project, since they canceled the one up in Miami area, the next project is not scheduled yet that I know of. But the other supplier is a US Polygo out of, both of them are in the Dallas area. And there's the specifications. The specification has been written since 94, 95. Definitely a new and interesting rubber. Ground tire rubber specification. It hadn't been used a lot, but this is what we see. There's a polymer content. They still have to use a polymer to get the upper end of the specification to work. Under the wet process, the tire rubber only affects the lower end, the cold temperatures and the cracking on the low end. So that's why it's so expensive. They put in tire rubber, but they also have to put in polymer and carry that. The dry process, the issues, good or bad, the ease of use. You can turn the machine on, you can make 5 tons or 10 tons and turn it off. With the wet process, you have to order a whole tanker load or partial tanker, and then you have to use the liquid up. The difficult issue is to grade the dry process. You have to have a special equipment in there, a special piece of equipment in the lab to make it work. And you have to have a blower at the asphalt plant to introduce it into the GTR. But the additional polymer is not needed to complete the PG grading, which is another cost savings. Now, when I say all these are issues, they're good or bad, but can be overcome. We placed a project on State Highway 3 in Canadian County, going west from State Highway 4 about 6 miles. And there's a 1,100 ton project in the middle of that with ground tire rubber, 880 tons to be exact. And we put 5% ground tire into the mix. And I was on the project about 2 weeks ago, 3 weeks ago. Fantastic looking mix. And we did it in cooperation with Stick Funds, and Asphalt Plus participated in it. The project's performing very well. And the next project has been identified in Elk City on I-40B. This will be about 30 to 40,000 tons of mix. And the next project after that is up in, I think it's Texas County, up in the Panhandle. So the future, this is really where we're going to try and be. ODOT will control the use of the GTR mix. There's very specific things you got to do. The next projects have been identified with even more in the making. The big couple of questions that we have is, can we get to the point of using Oklahoma generated tires only? And I think that's going to be, I know Red and his group and Farella have been really pushing for that. I think we're on the road to that, getting it done. And then GTR, we're putting a GTR mix, a ground tire rubber mix on the NCAT track, which won't go deep into it, but the NCAT track is a test track down in Auburn, Alabama, that we put 200 tons down, 200 feet of mix, and figures out to be about 80 tons. And we let it sit there for 3 years, and we load it, and we load it with heavy trucks, 120,000 pound trucks, and the axle spaced correctly, and we put 20 years of life in on a pavement section in a matter of 3 years, 2.5 years. And right now they're working on the design now. Red and I talked about it earlier. And it'll be going down mid-September and start loading around mid-October. So in 2 to 3 years, we'll really be able to see the benefits of rubber on the track. Another use that we have talked about and seen is rubber chip seals. They'll make, instead of a real fine crumb rubber, they'll make a playground type 1/2 inch and put it down in chip seals, about 50-50. It's been performing well. I talk to the Missouri people once every 6 months, and they're having good success with this. Just going back to reiterate what Red had said about costs associated with GTR. Well, I'll just let his stand on its own. So if you have payment projects that you'd like to do a demonstration project, we do have a special provision out. It's taken me about 2 years to write it, refine it, and put it into the hands of our residencies and our districts, and they're using it. And one thing that it does allow that Oklahoma does not allow right now is recycle asphalt pavement in surfaces. And with these new mixes and better quality liquids and that kind of stuff, we're able to put about 10 to 15% recycle into driving surfaces of Oklahoma. So it's been a challenge. It's been, I know I went through a lot of different bullet points real quick. I appreciate your time. But again, if you have questions, concerns, or projects that you'd like to see go down, especially in Oklahoma and on, even if it's shared cost projects, we'll be happy to help you. So if with that, does anybody have questions?
Thanks, Kevin. If you want to go ahead and check your chat box, I don't see anything on the chat box here.
Yeah, I'm trying to get down to it. There it is. No, nothing there.
Okay. Farella, if you and Redmond want to check your chat boxes again one more time.
This is Red. I have checked. There are no questions in mine.
Okay.
No questions in mine.
Okay, if someone thinks of a question after the fact, you can email them to me or Chelsea, and we'll be glad to forward those on. Since we don't see any chats in the chat box, I guess that will end our session for this afternoon. So thank you, Farella, Redmond, and Kevin. Thank you so much for presenting. And don't forget to join us again Thursday morning, starting at 8:30 for the NEPA resources. So with that, Farella, happy retirement and good luck with your new position. And thank you guys for joining us this afternoon. We really do appreciate it. And everyone have a good evening.
Thank you. Thank you, Karen.
Thank you all.
Thank you. Bye.
Bye-bye.